Hello friends, welcome back to our channel. So in today's session, we'll discuss about the SLR parser to construct the parse string. So before going to that, so let us see the introduction. So here, what we have to do means, first take the productions and first find out the LR of 0 items and then construct parse table and consider a string generated from the productions or from the grammar and parse the string. So we need to parse the string because we need to check whether the parse table is correctly generated or not, right? So finally we need to design the parse string. So once the parse string was successfully generated, the string was parsed successfully, then we can design the parse string, right? So these are the steps we need to follow while constructing the parse string. So first we need to find the LR of 0 items for the given productions, right? So I'll explain with Excel so that everyone can understand. So let us take the productions. These are the productions. E tends to E plus T, E tends to T, T tends to T star F, T tends to F, and F tends to parenthesis E, F tends to ID. Now, before finding the LR of 0 items, first we need to find the augmented grammar. So augmented grammar means adding one more production for the starting symbol. So here E tends to E plus T. So I need to introduce one more production, new production for the start symbol. I need to change the start symbol, right? So previously it was E tends to E plus T. Now I am adding the production E dash tends to E and E tends to E plus T. So all the remaining productions will be same. So this production is newly added. This production is newly added, right? So this is called the augmented grammar. So first let us write the augmented grammar for the given productions, right? So E dash tends to E and all the remaining are same, right? All the remaining are same. Now the augmented grammar is ready. Now what we have to do? So we need to find the LR of 0 items. LR of 0 items. Now what exactly this item means? So we know the productions, right? So the grammar we call it as a production. Then what is this item? So an item means adding a dot at the beginning of the right hand side production, right? So for example, let us take the first. So E dash tends to E. So what we have to do? We need to add dot at the beginning of right hand side production. At the beginning of right hand side production. That means, so this should be written as E dash tends to dot E. E dash tends to dot E. So now this is called item, LR0 item. Now what we have to do? If the dot is having a followed by the dot is having a non-terminal, immediately after the dot we are having a non-terminal, then we need to write all the productions of that particular non-terminal. Write productions of non-terminal, right? Okay, hope you understood this one. So if the dot is having before the non-terminal, that means immediately the dot having the non-terminal, then simply we need to write the productions of that particular non-terminal. That means we need to expand. Right? Now this is called the items. Okay, LR0 items. We need to process this one. Now let us check here. LR of 0 items I am writing here. So E dash tends to dot E. So dot, we need to add the dot on the right hand side production. Now after the dot we are having a non-terminal, we need to expand the productions, right? So what we have to expand? So E tends to dot E plus T, right? And also E tends to dot T. And again we are having dot after T. So we need to write down the T productions. T tends to dot T star F. See, simply remember that we need to add a dot after each and every production. That's called LR0 items. Then we'll find out the states, because in the construction of parse table we need to find out the states. Okay, we need to use the states. So that's why we'll find out the states. Now I will add the dot for every production. F tends to dot E and F tends to dot ID. So you can observe here, so this is a terminal, so it should be in a small letters. So you can observe here, so E dash tends to E. So for all the productions we have added a dot. Okay, for all the productions we have added a dot on the right hand side. So starting the right hand side production with a dot. Now we need to traverse this dot to the end of the production. So that will be calling as a final item, right? So if the dot is at the end of the right side of production, then it will be the item. Now let us consider this as a I naught, the state I naught, right? So I will highlight this one. So this is I naught. Now just simply go with the I naught. Go to I naught, and here you can see first one dot E, right? Dot followed by the E. Now that means we need to travel this dot towards the end of the production. So first I will travel I naught, go to I naught on E. So find out the E on the right hand side productions. You can see this is the one production, this is the one production. Just send the dot towards the right side of the production. So one step right side. So E dash tends to E dot, and again E tends to, okay, so just search the non-terminal on the right hand side only. So don't search for the left hand side, search for the right hand side. If you search for the right hand side, so these two are the productions where we are having E on the right hand side. So we need to move the dot towards the right hand side, one step right hand side. So E tends to E dot, and E tends to E dot plus T. And now observe whether the dot is followed by the non-terminal. So here the dot is at the end of the production. Here a dot is having a terminal. So just leave it. So give the state as I1. So we need not expand the terminal, non-terminal. So if the dot is followed by the terminal, okay, then if the dot is followed by the non-terminal, then we need to expand the non-terminals. So just take the another state. This is another state. Now simply go to I naught, and I naught still having the productions T, right? Now I naught on T. Let us travel the I naught on T. Now consider the T on the right hand side. So we are having these two productions. So similarly, just move the dot towards the right hand side. So E tends to T dot, and T tends to T dot star F. So observe here, after the dot we are not having any parameter, any symbol here. Right? Here after the dot we are having the terminal. So we need not expand. So if the immediate symbol after the dot is a non-terminal, then we need to expand. Right? So just leave it and give the state I2. So because I1, I0 is there, I1 is there, now I2. So I will highlight the states and labels. Now, is it completed with I0? No. So there is one more thing, F. So I0 on F. So simply go to I0 on F. So what happens? So there is only one right hand side, that is this one, right? Dot F. So simply move the dot towards the right hand side. So T tends to F dot. T tends to F dot. So is there any other productions with a F on the right hand side? So here there is a F. So we need not process this one because dot after F, you need to consider this one. And yes. So simply stop it because here after dot we are not having any other symbols. So simply stop it. So give the state number 3, I3. So this is a I3, state I3. Now again go to I0 on completed F, and there is a parenthesis, I0 on parenthesis. We can also process this one because dot parenthesis. Now we need to check whether we need to move the dot towards the right hand side. So F tends to parenthesis dot E parenthesis. Now you can observe after dot we are having a non-terminal. After dot we are having a non-terminal. So we need to expand this one. So write down all the E productions. Write down all the E productions. So if you write down all the E productions, simply you need to use, see, these are the E productions. These are the E productions, right? So we need to write all these things, E productions. And after writing this one, again you can observe after dot E is there, we have written the E production, and coming to this production, after dot we are having a T. T is also a non-terminal. Again, expand the T productions. So these two are the T productions. So I am expanding these two productions. And after that, again you can observe dot T. So we have already expanded the T. So in the second production dot F. In the second production there is a dot F. So again we need to expand the F productions. F productions, right? Now in the F production you can see after dot there is a terminal. Here also there is a terminal, so leave it. So give the state as I4. Give the state as I4. Now after parenthesis there is a one more operation, that is a ID. Now go to I0 on ID. So ID is a terminal, right? So we need to write down the ID, this one. So move the dot towards the right hand side. So ID dot, right? So here you can observe after dot we are not having any symbols. So, and we need not expand any other productions, and consider this one, and the dot is on end of the production, right hand side production. So this is called the final state. This is called the final state or final item. So I5. So let us give the label as I5. So take it, right? So I will give the color, another color, because of see, this is the final state, final item. Now after completion of I0, we have completed the I0, right? So I0 on E, I0 on T, I0 on F, I0 on left parenthesis, and I0 on ID. So in each and every case we need to move the dot towards the right hand side. Then coming to the next, go to I1 on. So let us check with the I1. So in the I1, the first production, dot is at the rightmost, okay, at the end of the production. Coming to the second production, so dot can be traveled, right? So on plus, I1 on plus. So here just move the dot E plus dot T, and observe here after the dot we are having the non-terminal, right? After the dot we are having the non-terminal. So simply expand this one. So write down the T operations, I mean T production. In the T production, again we are having the F. So dot after dot we are having the F. So expand the F productions. Expand the F productions. Right? Now give the state as I6. So just give the label. Give the label. And again, whether it was completed or not, let us check I1 on T, right? It was completed, right? Now move to the I2. So I2, first production is completed, right? The first production is completed, T dot. Okay, dot is at the end of the right hand side. Now consider the second production. So go to I2 on star. I2 on star. Right? Now let us check this one. So T tends to T star dot F. T star dot F. Again observe. So dot after dot we are having the non-terminal. So we need to expand. So expand means we need to write the F productions. I will write the F productions here. Right? So that's the only production we can apply. So we'll give it as a I7. Give the label as a I7. Now after I2 was completed, go to the I3. So I3 is a final. Okay, I3 is also a final state. So we can change it. Because in I3 only one production is there. In that production also dot is at the end of the right hand side production. So we can't travel the dot. Okay. Now go to the I4. So I4 we are having a lot of productions. I4 on E. So go to I4 on E. Go to the I4 on E. So you can observe we have to travel the dot towards the right hand side. So dot parenthesis dot. So dot will be moved E dot. So this production is changed to F tends to E dot. And again there is one more E on the right hand side. So you can change this one. E tends to, so E dot plus T. And you can observe in these both productions we need not expand the non-terminals because after dot we are not having a non-terminal. So simply you give the state as I8. I will give the state as I8. Right? So like this we need to find all the states. So let us calculate all the things. Now just a second, I will write here itself. Okay, right. So I4 on E is completed. Now we'll check I4 on T. I4 on T. So go to I4 on T. So if it is I4 on T, okay, I4 on T, see here I4 is this one. T means here we are having only one production. So T tends to, okay, two productions. So E tends to T dot and T tends to T dot star F. Okay, so these are the two productions we are having a T on the right hand side. Okay, in the I4 T. So T dot and T dot star F. T dot star F. So here we need not expand any other non-terminals because after dot we are not having any non-terminal. So simply leave it and you can give the state, and before giving the state number you check whether these productions are repeated productions or not. And here you can see in the I2 the same productions has been repeated. E tends to T naught and T tends to T dot star F. So simply give the same state here, I2. Same state number because both are the same productions. Now I4 on T is completed. Now I4 on F. So simply go to I4 on F. So we are having only one production on the right hand side, F. So just expand this one. T tends to F dot. So only this one. We need not expand more because after dot there is no terminal or a non-terminal, and this is the final state. And let us check whether it was repeated or not. Yes, so this is repeated. This is a I3. So simply give the same state name, I3, right? So consider whether it was completed or not. I4 on F is completed. Now again I4 on parenthesis, left parenthesis. We need to check with left parenthesis. So let us write here. So go to I4 on left parenthesis. I4 on left parenthesis. If you go to with the I4 on left parenthesis, you can see this one, expand this one. So F tends to move the dot towards the right hand side. So parenthesis dot E, close the parenthesis. Right? Now you can observe after dot we are having a non-terminal. So expand E, so that write down the all the E productions. So these two are the E productions. Simply copy and write down the E productions. Right? So after writing the E productions, right? After writing the E productions, simply see. Again see, there is a dot. After dot there is a non-terminal. So T, expand this one. So write down the T terminals. So T productions. I'm writing the T productions. And here we are having again after dot F. That means again non-terminal. So write down the F productions. Write down the F productions. Right? And here we are not having any non-terminal after the dot. So just leave it. And now before giving to the state number, check whether it was repeated or not. Yes. So you can see here. So the same thing. I4 is repeated here. I4 is repeated. All the productions are same. So give the same name I4. Give the same name I4. Right? Now, so I4 on parenthesis completed. Now I4 on ID. We need to go with I4 on ID. So go to I4 on ID. So now just move the dot towards the right hand side. So F tends to ID dot. ID dot. So this is also a final item. And check whether it was repeated or not. Yes, it was repeated. So this is I5, right? So give the same state number I5. I5. So the process is simple. Just follow this one, and I4 is completed. Now go with the I5. So here we can't expand the I5 because I5 is a final state. Go to the I6. So yes, in the I6 we can do the process because so dot is not at the end of the right hand side production. So I6 on T. Let us start with the first one. I6 on T. So go to I6 on T. Now what happens here? So E tends to E plus T dot. Okay, E tends to E plus T dot. And again T tends to T dot star F. So we are having a T on two productions on the right hand side. So we need to move the dot for the two productions. So E plus T dot star F. Right? So it was not repeated anywhere. So check once. So it was not repeated. So give a new state. So what is the new state here? I8. So it is I9. So this will be the I9. This will be the I9. Right? Now after that, so consider once again consider. Sorry. Right. Now I6 on T completed, and you can say I6 on F. So there is a I6 on F. So go to I6 on F. So what happens? We are having only one production on the right hand side with the F. So T tends to F dot. T tends to F dot. So simply after dot we are not having any terminal or non-terminal. Simply we need not expand this one, and this is a final item. And let's check whether it was repeated or not. Yes, it's a I3. It's a I3. So give the same state name I3. The same state name I3. Right? Again, consider I6 on F is completed. Now I6 on left parenthesis. I6 on left parenthesis. Go to I6 on left parenthesis. Right. Now consider this one. F tends to left parenthesis dot E. Left parenthesis dot E. So this dot will be moved towards its right. So left parenthesis dot E. Now you can observe again the after dot we are having a non-terminal. So expand the E. So write down all the E productions. I will consider these E productions here. Right. And again we are having a non-terminal after dot. So that is T. Again we need to write the T productions. I will write down the T productions. Here after dot we are having F. Again non-terminal. We need to expand the F productions. Right. So you can observe this is again it's a I4. This is again I4. So just give the name as I4. The state I6 on left parenthesis is I4. Again go with the I6 on ID. I6 on ID. So I will write here. So I6 on ID. So only one production is there, right? With the ID on the left hand side, sorry, right hand side. So just change that one. F tends to ID dot. So is it repeated? Yes. It is repeated, right? So it was repeated. That is nothing but I5. Okay. It's nothing but I5. So simply write down I5. I5. Now the F6 I6 was completed. Now go to the I7. Again I7 is having F, right? So we can process it. So go to I7 comma F. So if you process this one, right? If you process this one, so dot should be moved towards the right side. So T tends to T star F dot. F dot. So only one production is there where F is on the right hand side. Simply leave it and just check whether it was repeated or not. So there is no repetition. So give the state, new state. So where we have stopped I9. So this will be I10. This will be the I10. And I7 is completed? No. So I7 can also be processed with parenthesis and ID. Now consider go to of I7 with parenthesis. I7 with parenthesis. So parenthesis means this one. So simply process F tends to parenthesis dot E. So that means expand the E productions. So if you expand the E productions, write down the E productions here. So if you write down the E productions here again, we are having the T after the dot. So which is a non-terminal. Write down the T productions. Again write down the T. After writing the T productions, you can observe there is a F which is a non-terminal after the dot. So again expand the F productions. Right. So this is repeated. This is repeated. This is nothing but I4. I4. So it's nothing but I4. Give the same name. Right. Now after that, is it completed? No. We need to process the ID also. I7 on ID. So I'll write here. So go to I7 on ID. So what happens here? ID. So the dot operator the dot should be processed towards its right. So F tends to ID dot. ID dot. So let us check whether it was repeated. Yes, it's a I5. The state I5. It was a state I5. Right? Now I7 was completed. Go to the I8. So I8 can be processed because dot is not at the end of the productions. So I8 on right parenthesis and I8 on plus. We can move like this. So simply go to I8 on right parenthesis. I8 on right parenthesis. Now I8 on right parenthesis, you can see this production F tends to, so right parenthesis E, right parenthesis and dot. So E dot, right? So this is a final item, right? So it was not repeated. You can give the name The state is I11 now. I11, the state is I11. Now, again, we need to process I8 with plus. Go to I8 with plus. So what happens here? You need to expand this one, right? So E tends to E plus dot T. So again, after dot we are having the T. After dot we are having the T. Expand the T productions, right? Write down the T productions here. I am writing the T productions, and after writing the T productions, again we need to write the F, because after dot we are having a non-terminal. So write down the F productions here. We'll write the F productions, right? And you can observe whether it was repeated or not. So once you observe from the beginning, see here, these are the productions repeated. These are the productions repeated, right? So the state is, give the same state I6. Give the same state I6, right? So I8 is processed. Now I9, go to the I9. Where is I9? The state I9. So in the I9, again we can expand with a star. I9 we can expand with a star. Now simply go with this one. So go to I9 with star. So only one production, because the above production was already, the dot has been processed towards the last of the right side production, right? So dot is at the end of the right hand side production. Now we need to process this one only. So star dot star. So T tends to T star dot F. T star dot F. So again write down the F production, because after dot we are having the non-terminal. So write down the F productions. So I will write the F productions here and see whether it was repeated or not. We'll check. Yes. So you can observe here I7, T star dot F and F productions. T star dot F and F productions. This is a I7, right? So this is the state. Now I9 on star completed. Go with the I10. So I10 is a final item. Okay, I10 is a final item. So you need not process it, right? And again I11, go to the I11. I11 is also the final item. You need not process. Go with the I12. So there is no other state with I12. So we have already covered all these things. So we need to stop now, right? We need to stop. So the process is lengthy, but the procedure is very simple. The first thing, consider the productions and write down the augmented grammar by adding a new production for the start symbol, and consider the LR of 0 items. That means add dot on the right hand side. Start the right hand side production of every production with a dot. So E tends to dot E, E tends to dot E plus T, and E tends to dot T. Now consider the state as I0. Now we need to process I0 with all the terminals and the non-terminals, right? So dot E. So we need to process I0 on E, because the dot should be processed towards the last of the right hand side. Okay, end of the right hand side production. So it is dot E. So we need to process E. So find out the E on the right hand side. So E on the right hand side, we are having these two productions. Now just use these productions. That means just move the dot towards the one step towards the right side. Move the dot one step towards the right side. So E dash tends to dot E, will becomes E dash tends to E dot, and E tends to dot E plus T will be moving as E tends to E dot plus T, right? So observe whether there is a terminal or a non-terminal after the dot. So if there is a terminal after the dot, if there is a non-terminal after the dot, expand that particular productions. So here we are not having. So after dot there is no other terminal or non-terminal, and here we are having a dot. After dot there is a plus, that is a terminal. Leave it. Now consider this one. See, consider this example. So F tends to parenthesis dot E. So now dot, after dot we are having a non-terminal. So we need to write the productions of this particular non-terminal. So expand this one. So write down the productions of this particular E. So these two are the productions of E. I have written these two productions of E. And again check whether again there is a a terminal after the dot. So after the terminal dot there is a E, so we have written already, and in this production we are having T after the dot. So again expand T, so write down the T productions. We have written the T productions, and then again check. So there is a one more expansion, that is a dot F. So F is there after dot, so write down the F productions. You just follow the same procedure until you process all the states, until you process all the states, right? So this is the first step. So we need to construct the canonical collection of LR of 0 items, right? So hope you understood this one. So after that we will construct the parse table. Now let us see the number of states, and we'll construct the parse table. So before constructing the parse table, first let us let us note down the final states, and we'll find the follow for all the non-terminals, right? So based upon that we need to fill the parse table. So first let us write down the final states and the follow. So I will write in one more Excel so that it will be very easy for understanding. So here I'll write. So final states and reduced terms. Reduced terms are nothing but our follow, right? So see the final state first. Here you can observe the final state, that is I1. In I1 we are having the final state E dash tends to E dot. So the state we will call it as a final state when the dot is at the end of the right hand side production. So here we are having the right hand side production E tends to E dot. That's one final state. I will write down that one. So E dash tends to E dot. E dash tends to E dot. So that is available in the state number 1. So I1. Next, coming to the state 2. So I2 is also having a final state, that is E tends to T dot. E tends to T dot. And then I3 is also having the final state. So that is T tends to F dot. Next, I3. I5. So we have already mentioned here. So I5, it's having the final state F tends to dot ID. Sorry, ID dot. So the dot should be at the end of the right hand side production, ID dot. So after I5, so we are having I9. So I9 is having the final state E tends to E plus T dot, and after that 10. So I10 is having one more final state, T tends to T star F dot. So I think completed, or yes, one more thing is there, that is a F production. I11 we have I11 F tends to, in the parenthesis we'll use a E and dot, in the parenthesis E dot, right? So these are the final states. Now give the order based upon this augmented grammar, right? So this is R0, R1, R2, R3, R4, because these are the reduced terms. By using this one, we are going to reduce the grammar, right? So first E tends to E, that is nothing but R0. And next E tends to T dot, so that is R2. E tends to T dot, that is R2. Right? Next T tends to F dot. T tends to F dot is R4. So R4. And next F tends to ID dot, it's F R6. R6. E tends to E plus T dot, that's R1. R1. And T tends to T star F dot. T star F dot, that's R3. And F tends to E dot, that is R5. Right? Now we had the final states and the corresponding reduced terms, right? Now we'll see the follow, right? So this is the initial state. E dash is an initial state, so this will be accepted state. Okay, this will be the accepted state. And coming to from the next one, we need to find out the follow. We need to find out the follow. Follow of E is equal to, sorry, follow of E is equal to, so I have already done this one. So just go through the previous sessions how to find the follow and find out. So I'm directly writing the result. So plus dollar and right parenthesis, right? And the next one, follow of T, follow of T is equal to, so plus dollar right parenthesis and star. Similarly, follow of F is equal to star plus dollar and the right parenthesis Next, follow of follow of E is a same, okay, and T, follow of T is also same. So we'll write the follow of E because this production is of E, so we'll just note on the same thing, we'll copy the same thing, follow of E here, and this is of T tends to T star F dot, so we'll go with the follow of T. So based upon these terms, we need to fill the parse table. This is F, so follow of F. So note down like this, right? Now we need to fill the parse table. The parse table will be containing two terms. One is a action, another one is a go to. So here the action means for the terminals and go to for the non-terminals. First, let me write down the states I0, I1 and so on up to I11. So total 11 states we are having, right? Total 11 states. And here, so we are having the terminals ID plus star right parenthesis, left parenthesis, right parenthesis, and finally that dollar. And the non-terminals E, T, F, right? So this is the parse table we need to fill. So how to fill this parse table? We'll see one by one. Right, see. So check now. So all the terminals comes under action and all the non-terminals will comes under go to, right? So always remember that the one with a dollar is an accept state. One with a dollar is an accept state, right? So now let us check according to this one. So come with order I0 on E, right? So I0 on E, it goes to I1. So I0 on E goes to I1. So if it is a non-terminal, just give the number 1. And I0 on T moves to I2. I0 on T, it moves to I2. That means 2. I0 on F, it is 3. So I0 on F, it is 3. Next, I0 on left parenthesis, it's I4. So if it is a terminal, use S symbol, S for shift. Okay. So I0 on left parenthesis, I4. I0 on left parenthesis, it will be S4, right? So it's a fourth state. Here we need to use a shift, right? If it is a terminal, use the S symbol, yes. If it is a non-terminal, use the numbers, state numbers, right? And after that, I0 on ID goes to I5. I0 on ID goes to I5, so S5, right? And I1 on plus, here I1 on plus move to I6. I1 on plus move to I6, that means S6, right? Next, I2 on star moves to I7. I2 on star moves to I7, so it will be S7 because of its terminal. So I4 on E moves to I8. I4 on E moves to I8. So it's a non-terminal. So simply give the number. and I4 on T moves to I2. I4 on T moves to I2. I4 on T moves to I2. So give the number. I4 on F moves to I3. I4 on F moves to I3. So give the 3 as a number. Then I4 on left parenthesis I4. I4 on left parenthesis I4. Simply go with the S4. And I4 on ID moves to I5. I4 on ID moves to I5. So it's a S5. And I6 on T moves to I9. I6 on T moves to I9. So give the number 9 because of non-terminal. Right? I9 of, sorry, I6 of F goes to I3. I6 on F goes to I3. So give 3 number. I6 on ID goes to I5. I6 on ID goes to I5. So S5 because of its terminals. These are the terminals. I6 on left parenthesis I4. I6 on left parenthesis I4. This is a S4. And I7 on F goes to I10. I7 on F goes to I10. So give a symbol 10. Then I7 on ID goes to I5. I7 on ID goes to I5. So S5 because it's a terminal. And I9 on star. I9 on star gives to I7. I9 on star goes to I7. So S7. So this is a S7. Right? I think, yeah. So I7 on left parenthesis. I7 on left parenthesis. It moves to I4. I7 on left parenthesis. It is a I4. Then I8 on right parenthesis I11. I8 on right parenthesis I11. So it is a S11 because the right parenthesis is a terminal, right? I8 on plus goes to I6. I8 on plus go to S6. Right? So these are the terminals and the non-terminals. And these are the states. These are the states, right? So we are filling the shift. Shift is completed. So simply you can say yes for shift operation and R for reduce operation. So we need to apply only these two. Okay, shift and reduce. So we have completed the shift operations and now we have to apply the reduce operations. So how to fill with the reduce terms? Simply go with here, right? So I2 is having the final state E. Okay, so which is nothing but a R2. R2 means the production 2, right? So go with the follow of E. So because this is a E production, the follow of E. So fill the I2 on plus dollar and right parenthesis with R2. Okay, so this is the first, I mean, this is one final state. E tends to T dot is the final state, which occurs in I2 state, and this is the production number 2. So previously we can see E tends to T naught. E tends to T naught is the production 2, second production. Consider the productions, right? This is the second production. So we need to use a reduce 2. And similarly, so find out the follow of E so that whatever the terms we are getting here, you fill 2 corresponding to all these terminals with R2. So here you can see I2 on plus dollar and right parenthesis fill with R2. So I2 on plus is R2, I2 on dollar R2, I2 on right parenthesis R2. Right? So hope you understood this one. Similarly, go to the next one. I3 on, this is a T production and that is a fourth production, and find out the follow of T and fill the corresponding 3 corresponding with all these terminals with a R4. So I3 upon plus go with the R4, and I3 upon dollar R4, and I3 upon parenthesis R4, and I3 upon star R4. Similarly, go with this one. Next, I5 upon star, it's a R6. I5 upon star R6, reduce 6. Okay, so I5 upon plus R6, and I5 upon dollar R6, and I5 upon right parenthesis
It's again R6. Then this I9, right? So all these are the, remember, all these are the final states. So these are the state numbers where we got this final state. Okay, final item, we can say it as a final item. So without confusion, I will write here, it's a final item, and these are the final states. Okay, these are the final states, and this is a final item, and this is nothing but a production number. These are the production numbers, right? Now we gone with the R6. Now I9 upon plus, I9 upon plus, it is R1. I9 upon dollar, R1. I9 upon right parenthesis, R1. And similarly, I10 upon plus, R3. R3. I10 upon dollar, R3. I10 upon right parenthesis, R3. I10 upon star, R3. Right? Similarly, I11 upon star, it is R5. R5. I11 upon plus, R5. I11 upon dollar, R5. And I11 upon parenthesis, right parenthesis, R5. Right? So these are the reduce operations. These are the reduce operations. So we have successfully completed the parse table. We have filled the parse table. We have filled the parse table. So once again, I'm repeating. So first, write down the follows, write down the productions. That means the final items. So where we got the final item. So once again, I'm repeating, the final item means the dot should be at the end of right side production. So just write down the final productions and write down the corresponding states where we got this final item. So here, from here, you can get the state number from where you got the final productions, right? So then corresponding, give the production numbers. So the starting productions, give the numbers for the starting productions and fill them with the production numbers, right? So fill them with the production numbers. Now simply use the thing. So find the follow for each and every non-terminal and fill the follow, right? So here, this is the E production, write down the follow of E. This is a T production, write down the follow of T. F production, find out the follow of F. E production, find out the follow of E. T production, find out the follow of T. F production, find the follow of F, right? So already we have discussed about how to find the follow in the previous sessions. So I will post the link in the description. So you just go through that and find the follow of all the non-terminals. And now use the table, create the table with all the states and two terms, that is the action and go to. Action consists of all the terminals and go to consists of all the non-terminals. Now upon the states, see, upon I0 on E, go to the I1. So upon I0 on E, go to the 1. So if it is a terminal, if it is a non-terminal, just give the numbers. If it is a non-terminal, give the S value. S followed by the state number. So S stands for shift. So once you complete these shift operations, then based upon the follow of these non-terminals, so the state upon the follow of this non-terminal, fill the reduce values. So R2. So for this production, this is the R2. So I2 upon plus dollar and right parenthesis, fill the R2. R2 means reduce, right? Similarly, I3 upon plus dollar parenthesis and star, fill the R4. So R4. So like this, we need to fill the parse table. Now the parse table has been completed. Now the next step is we need to consider one string generated from the productions and we need to parse that string whether we are getting the correct answer or not, right? So finally we need to apply the shift and reduce operations on the string so that we need to get the accept state. Accept state means 1 upon dollar. So this is the accept state. So finally we need to get this accept state, right? So now we'll generate one string from the productions and we'll do the parsing, right? We'll parse the particular string so that we'll check whether the parse table is constructed correct or not. Now we'll consider a string will generate the string from the given productions, right? So here the given productions are so from the given productions, let us generate a small string, right? So first let us start with the e tends to e plus t, and in the place of e we can substitute t. So here we'll substitute t, so t plus t, right? And in the place of t we can substitute f from the production t tends to f. So f plus, again here also we'll substitute f, and in the f we can directly give the terminal id, so id plus id, right? Now let us consider this a simple string. So this is a string generated from these productions. So if you parse this string with the help of parse table, so it should be, we should get the accept state, right? So let us consider this string id plus id, right? Now let us consider, let us take the three terms. The first one is a stack, next one is the input string, and the next one is a action, whether we need to reduce or a shift. Okay, so initially the stack consists of dollar and the input string id plus id, and at the end of the string dollar. In order to represent the end of the string, we'll take the dollar, right? So hope it is visible to everyone. There is no problem with that, right? So here let us consider right. So initially the stack value is dollar, right? And the input string is id plus id dollar, and initially there will be no action. So now let us start with the initial state. So I am pushing 0, the initial state, to the stack, and the string is same, and now we need to find out 0 upon id. So 0 is the top of the stack and input string is id. So just follow the parse table and take the action on 0 upon id. So what action it was, either reduce or shift. So according to the parse table we'll find 0 on id. So this is a parse table we have constructed. 0 upon id, this is S5. S stands for shift and R stands for reduce. So if 0 on id, it is S5. So here S5. S5 means shift 5, right? Shift 5. So if it is shift 5, what we have to do? We have to shift the first term in the input string into the stack. So $0, what's the input string here? ID. So push the ID and then push the number, the state number, that is a 5, right? So hope you understood. 0 upon ID is the shift 5, right? Shift 5. If it is a shift, just push the input string, the first element of the input string, to the stack, and then push the state number to the stack. So 0, ID and a 5. And here now the input string is plus ID and dollar. Sorry. Okay, as this is a Excel, so it doesn't accept the plus, right? So we'll just, for understanding, I'm writing some plus. Okay, so don't get confused. Plus is for representing the operator plus. Okay, plus ID dollar, plus ID dollar. So here now 5 on plus, 5 on plus. So go to the parse table. 5 upon plus, it's a reduce 6. It's a reduce 6. So R6. So what is the R6 here? Just go to the here. R6 is F tends to ID. So here it is a F tends to ID, right? R6 is a F tends to ID. Now just observe, if the production f tends to id, whatever the production it may be, the reduced production. So on the right hand side, just count the number of elements. So if the count is 1, we need to pop the 2 elements from the stack. If the count of elements is 2, we need to pop 4 elements from the stack. If the count is 3, pop 6 elements from the stack, right? So 2 into number of count. So here this is a reduce operation. So reduce R6. R6 is f tends to id. See, R6 is f tends to id. On the right hand side, we are having only one element. So we need to pop 2 elements. Okay, we need to pop 2 elements. So here I will write the action. So push input string, then state number, right? Input string and state number. Here count number of elements on right hand side of production and pop 2 into number of elements, okay, from stack, right? So just for better understanding, I'm writing all these things. See, now remove the 2 elements, that is 5 and id will be removed. So $0, and now push the f, right? Push the symbol non-terminal 0f. So here it will be plus id and $. And here what action you need to take? So 0 upon f. So consider 0 upon f, because f on plus, there is no state number here, right? So the top of the stack is, it's a non-terminal. So we need to get the state. So find out 0 upon f. So 0 upon f. So 0 upon f, it is a 3. So give the action 3, right? Shift the 3. Now push state number to stack, right? Push the state number to stack. So next it will become 0f3, and here it will be plus id $, right? So here after that we need to consider and push LHS non-terminal on LHS to stack, right? Now right, now see, now 3 upon plus, so go to the parse table, 3 upon plus, it's R4, right? R4. So let us check with the R4. T tends to f, so it is T tends to f. Now the same thing apply. Count the number of elements on RHS. On the RHS of production, we are having only one element, and pop 2 into number of elements from stack, 2 into 1, 2 elements from the stack, and push non-terminal on LHS onto stack. So remove this f and 3, because on the right hand side production we are having only one element f, so 2 elements to be removed from the stack. So $0 and push the non-terminal on the left hand side to the stack, so T, and here it will be plus id. Now here what action to be taken? So T on plus, there will be no element for this particular table, right? So we need to get the state number. So 0 upon T, find out 0 upon T. It's a 2, right? So 2. Now push the state number to the stack. So it will become $0 T2, and here it is common plus ID dollar, right? So 0 T2. Now 2 on plus, 2 on plus, again reduce R2. R2. What is the R2? R2 is E tends to T. E tends to T. E tends to T. Now you can observe the same thing. First count the number of elements on the right hand side. So only one element. So we need to pop two elements from the stack. So $0, T and 2 has been removed, and push the non-terminal on the left hand side production to the stack. So E, and here again it is plus ID and $. So here we need to get the state number. So 0 and E. So push the state number 0 upon E. So 0 upon E, it's a 1. So take 1. Now push the state number to the stack. So $0 E1. And here it is the same, plus ID and $. So G1 on plus. So 1 is the top of the stack and plus is the input string. So 1 on plus. So 1 on plus. It's a shift 6. It's a shift 6. So push the input string. First push the input string. So $0 E1. What is the input string here? Plus. Okay. And then push the state number. So 6 is the state number. 6 is the state number. Now the input string will be ID and $. ID and $. Now what happens here? 6 on ID. Right? 6 on ID. So 6 upon ID is again S5. So shift 5. So again same, apply the same. So first shift, sorry, S5. Right? So 6 on ID. Let us check. 6 on ID S5. Right? Now push the input string first and then the state number. So you apply the same thing, and after that just push the ID, input string, and then the state number 5. Now the input string becomes empty. That means a $. Right? The input string is $. Now 5 upon $. 5 is the top of the stack and $. So 5 upon $. R6. So now you need to go with R6. What is the R6? So just above we have written this R6. So what is this? F tends to ID. Yes, F tends to ID. And same, count the number of elements on the right hand side. Count the number of elements on the right hand side of the production and pop 2 into that many count from the stack. So only one element is there. We need to remove the 2 elements. So it will be a $0 E1 plus 6. Okay, ID and 5 has been removed, and push the non-terminal on the left hand side of the production to the stack. So F, and give the $. So there will be no element for F on $. So we need to get the state number. In order to get the state number, go with the 6 with F. So 6 upon F, it's a 3. So it is a 3. Right? Now push the state number to the stack. So $0 E1 plus 6 F and 3, and it's a $. Now again 3 on $. 3 on $. It's a R4. That means a reduce 4. So R4 means here T tends to F. So if it is T tends to F, again we need to remove 2 elements from the stack, because on the right hand side of the production we are having only one element. So count the elements and remove the 2 into that many elements from the stack. So $0 E1 plus 6. So F and 3 has been removed here. F and 3 has been removed, and push the non-terminal on the left hand side to the stack. So T, and it will be the $, and there is no element for T on $. So we need to get the state number. So go to the 6 upon T. So 6 upon T, it's a 9. 6 upon T, it's 9. So here go with the 9 and push the state number to the stack. Push the state number to the stack. So simply you just push it. So $0 E1 plus 6 T and 9 upon dollar. So 9 upon dollar now, right? 9 upon dollar, 9 upon dollar. It's a R1. It's a R1. So what is the R1 here? Just go with this one, R1. It's a E tends to E plus T. So E tends to E plus T. Now you can observe the count on the right hand side of the production is we are having 3 elements, E, T plus and T. That means there are 2 non-terminals and 1 terminal. So what we have to do, we need to remove 2 into 3. That means 6 elements from the stack. 6 elements from the stack. So you can remove 9, T, 6 plus 1 and E. Total 6 elements. So these are the 6 elements. Okay. E1 plus 6, T9. All these 6 elements has been removed. So now the stack is having $0 and push the non-terminal on the left hand side to the stack. So E and go to the dollar. So E upon dollar we will not get any entry. So we need to get the state number. So 0 upon E. Go with the 0 upon E. It's a 1. So it is a 1. Now what we have to do? Push the state number to the stack. So it will be $0 E 1 and dollar. Now go with the 1 with a dollar. So 1 upon dollar. It's a accept. It's a accept. Right? Accept. So what we have done? So we have started parsing the input string with the help of this parse table. Finally we got this accept state. So if you got this accept state, that means our input string is parsed successfully, so that we can generate the parse tree. So we can also generate the parse tree, right? So once again I am saying, so first input stack will be, by default it will be $, and the input string we have generated from the production. So we have taken one input string. So you can take any input string, right? So initially there is no action. So first let us start with the initial state 0. So push the 0 to the stack and 0 upon ID. Go to the parse table, 0 upon ID, it's a S5. So here we are doing 2 operations, the shift operation and the reduce operation. If you are using the shift operation, you need to shift the input string first and then the state number. So it is S5. So first we need to push the input string, that is ID, and then 5. And now the input string becomes plus ID $. So here just observe, don't get confused. I am writing in a words, plus in terms of words, because it's a Excel. So if you are using plus with the starting, so it will be calculating some formula. So that's why I'm representing the operator plus, the symbol plus with text. Okay, it's string. So plus ID $. Now 5 upon plus. So 5 upon plus, go to the parse table and check 5 upon plus. It's a reduce. If it is a reduce, go with the reduce number R6. So go to the here R6, we are having the ID, F tends to ID. So F tends to ID. So here we know that production will be having the left hand side and the right hand side. Left hand side will be having the non-terminal and the right hand side will be having the combination of terminals and non-terminals. Now count the elements on the right hand side of the production. So if the count is 1, just remove 1 into 2. That means a count into 2 elements from the stack. Right? So if the count is 2, we have to remove 4 elements from the stack. If the count is 3, we have to remove 6 elements from the stack. So here if you observe the count is 1, so 2 elements should be removed. That is ID and 5 has been removed. And after removal of this thing, the 2 elements, push the left hand side non-terminal of the production to the stack. Okay. And now observe F on plus. So there will be no entry for F with a plus. So we need to get the state number. So just to follow the 0 upon F. 0 upon F. So go to the table and 0 upon F. It's a 3. So here the action is 3. So just push the state number to the stack. So just push the 3 to the stack. Now we got the 3 and plus. So now check 3 with the plus. So 3 with the plus R4. So reduce 4. So reduce 4 means again we are getting the production R4 T tends to F. So only one element is there. So 2 elements will be removed from here and the leftmost non-terminal will be pushed into the stack as well as, so 0 upon T, it is a 2. Now again 2 will be pushed into the stack. So this is how we have parsed the input string and finally we got the accept. Okay, finally we got the accept. Now you can observe from this the last step. The last step is construction of parse tree. How can we construct the parse tree? How can we construct the parse tree? See, let us start here. So consider from bottom up. So this is a bottom up parser. So bottom up. So consider the last production. This is the last production, right? So E tends to E plus T. Consider this one. E tends to E plus and T. Now next production T tends to F. So T tends to F, right? So these are the nodes. T tends to F. So next F tends to ID. So here F tends to ID. Next one E tends to T. So this is a E, right? E tends to T. Next T tends to F. Again T tends to F. F tends to ID. F tends to ID. Now you can see the leaf elements ID plus ID. So the leaf elements are ID plus ID. So which is nothing but our input string. Okay. So this is a bottom up. Finally, you need to construct the parse tree. So just go with the last terminal, I mean last production. So last production is E tends to E plus T. Consider from that one E tends to E plus T, right? And follow with the next one T tends to F. So remove T with F. Okay, F with ID. So F with ID and E tends to T. So E tends to T and again T tends to F. Again T tends to F and finally F tends to ID. So F tends to ID. So the leaf nodes you can observe ID plus ID. So this is how we can construct the parse tree. So you can take any string. You can take any string from the given productions and you can check with the parse table. Okay. So this is how we can construct the parse tree by using the SLR parser, right? So the first step we need to consider the LR of 0 items. Okay, first give the augmented grammar, go with the LR of 0 items, find out all these things and find out the states and then find out the follow of elements and find the final items and corresponding states and give the order of productions, and based upon all these things fill the parse table by using the shift operations and the reduce operations, right? And finally you need to construct one input string. You need to construct one input string and parse that input string based from the parse table, and finally we should get the result as accept. Okay, we should get the result as accept. Once you got the accept, now start constructing the parse tree from bottom to top. This is a bottom up approach. So start with the last production and move upon with the first production. So finally you should get the input string, right? So this is all about our SLR parser. So hope you understood this one, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. Okay, and if you need this document, you just send an email to the comment box so that I will send this Excel document so that you can clarify your doubts. Okay, so if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.